Welcome to Rubber Duck Engineering. Today we are going to look at an interview question for a senior software engineering position. Hey Eric, how you doing?
Good. Well, all right, at least. It's been a crazy week, both at work and in the world, and it's just nice to be hanging out with friends on a Thursday afternoon.
Yeah, I stayed up last night watching a lot of news streams, and yes. But yeah, I think today we got an email from a colleague of ours who watches the show, and he sent us an interview question that he's used in the past to interview level 6 and level 7 software engineers. So level 6 and level 7, for those who don't know, that's a pretty senior.
It's quite senior
role. So this is like someone who like leads a team
Mhm.
of a substantial size to solve some pretty tough problems. And I think it's interesting to look at these kind of interview questions because they're pretty different from interview question you might get for like a junior software engineering role, and they're sort of different in structure. And so I thought it was a neat question. I thought we could look through it on the show and talk through it.
Yeah, to give a sense of scope, and individuals might disagree, but like ballpark would be like a level 6. You're setting direction for 10 plus kind of other senior people in designing a large software system, and 7, you're doing 30 plus or more in a large software system, and we're talking about hundreds of thousands, if not millions, of lines of code that you are setting direction for. Not that you have typed every one of them, but like these are very senior positions.
Yeah, I think one thing you'll see in the interview is it's not really about like typing in the code as quickly as possible. It's more about like what are the constraints of the design? How would you approach the problem? What are the trade-offs? Like that kind of aspect of the problem.
Yeah, I mean, I have given. It's been a while since I've been paid to type code. I do management stuff these days, but I have certainly given system design or design style questions where there really is no code typed. But anyways,
it also means there aren't really right and wrong answers, right? So that's another sort of interesting aspect of it.
Yeah,
it's a little tricky. Like normally when you do this, you'll have an interviewer who you can ask questions of or explore further. We don't have that. We just have the text version of the problem, but we're going to try our best.
Shall we move to the code machine or the design machine, I guess, tonight?
Sure. Hi, Edwin. I hope I'm pronouncing that correctly. We're doing okay. Hope you're doing well too.
Yeah, we can all step away from the news for a minute. Okay, so we have ourselves in a replit because I guess we do everything in replit these days. And this is the text the individual sent us. And said they were asking for want us to do this for L6, L7. Again, quite senior. You can look at levels at FYI to see what that maps to in other companies. And so this is to implement a file-like API. So again, you're not probably typing this out, and I think they explain this at the end of this text file. A file-like API that looks something like this. So if you've used a POSIX file system.
This is pretty standard. I mean, the person who gave us this question has a slightly Windows bent to it. So this thing has a slightly Windows bent to it, but it's otherwise pretty normal file system. You can open files, remove files, close them, like read them and write them. Could we scroll down and see what else we can do to the file?
And this is a C style API, although you could give the question with a different flavor if you wanted to. And then you're saying this is what you're backed by. So you have a blob service library, so something that'll hand you blocks of storage.
And this is very common in these sort of system design questions where you're not programming down to the metal. You're sitting on top of some other system, and your job is to transform the API provided by that system into some other API that your clients want.
Yep. Yeah, I remember a design question I was given. This was interviewing at Google 15 years ago, and this was for a much lower level position. I was asked to design like a selection, a data structure to handle selections in a spreadsheet.
Mm-hmm.
How would you think about that? And again, it wasn't a right or wrong answer. It was just like, well, how do you think about because it turns out selections are complicated, and also selections in a spreadsheet.
Yeah. So yeah, I think there's some other thing here where like there's sort of a maybe obvious and straightforward way of doing this, but I think that you want to start thinking about like what are the parameters of this problem like. Like we'll get to that as we get to more of his description.
Yeah, so here's the API that we're going to be given, and this is the description that we were given. So here's it goes. Given a blob API that allows you to read and write storage, write a file system that satisfies the file IOC API. In the interview format, 1 hour, the question is about designing the system, not the data structures, not typing code that implements it. There's simply not enough time to write the code. In a 3+ hour format, you can expect a candidate to implement FO, etc. Normally, I don't give specifications of the file system to be created. Yes, the question is really about creating a new file system, or if you have one memorized, type that out.
Maybe 1 in 10 or 1 in 100 candidates will have memorized the file system. But it kind of misses the point, actually.
Yeah, I think that's actually against the point, because often when you're interviewing a really senior candidate like this, they are really good at a specific thing like file systems. And I wouldn't actually want to ask them a file system question. Same thing. Again, I remember from 15 years ago, I was asked, because I had listed C++, I was asked, like, what are the 5 ways, what is it, the static keyword?
I always feel like those are like gotcha questions. Like I don't know. I've been doing this for a long time. Could probably figure it out, but does it matter? Like,
well, and again, but it is pitched that way. But the point is not that I got all 5 right. I actually don't think I did. But the point was then to prompt a discussion around like the weird ways in which, and make you think, because I had never thought about the fact that there were 5 different ways that the static keyword means in C++. But that was a question to probe my C++ knowledge, like things that you would have picked up along the way. And the same thing, if somebody was interviewing for a file system position, I wouldn't ask them this kind of file system question. I'd ask a probing question, to see what they got. But this would be a question for somebody who didn't do file systems. So I wait for the question to candidate ask good questions. We've talked about that before in the show.
Honestly, I think this is where these interviews are basically like your performance in interview is often the quality of the question that you're going to ask, less the actual quality of the designer code that you end up with.
And then give some specs, which again, I think we're kind of getting into the, I don't know that we actually need this. This is sort of, we can come back to this if we have questions as we go.
Well, I think there's some interesting things like the file size, for example, is more than 32 bits, but less than 64 bits, which is interesting. And the maximum number of files is just slightly more than 32 bits.
I see. Okay. Yeah, because you would ask these things in terms of sort of checking, understanding what your inputs are and your assumptions are.
Yeah, I once did an interview for a PM role, and I just totally failed the interview. And
you interviewed as a PM?
This is a long time ago. This is like the beginning of my career. Yeah.
Okay, and I had no idea.
But basically, I was talking to I could tell that the interview just had gone horribly, and so I basically asked the interviewer afterwards, like, what happened? They're like, and it's one of these like classic questions. I was supposed to design like a vending machine or something, and they said it was a vending machine for giraffes. The concept being like I had just assumed who the user was going to be, assumed the user was going to be a human being, and not even thought about the fact that like maybe it's important who the user of a thing is to design it. Anyway, it turns out I'm a better software engineer than I am a PM.
Well, there's another thing that I think actually is important in what you did there is that you did something with a chance of failure, which I think we often all don't do enough of. But okay, note that there's still a lot underspecified. This is meant to spur interesting conversations. The candidate let you tailor the problem to different skill sets. Yep. Importantly, a blob API is underspecified. For example, it's not clear what operation is synchronous, which are asynchronous. Yeah. Say put is async, but release is not. You could start with all the synchronous ops to begin with, or take it fully async if that strikes your fancy. One final note, there's no discovery APIs, so no directory listing, etc. The spirit is that the clients are server programs or higher level libraries that don't need that. Whoa.
Yeah, so when I look at this problem, the first thing I noticed in the blob API is there wasn't like a flush or a finish, or it really wasn't clear to me when the data was actually going to be committed to disk. And I think that's kind of okay because there also in the C API, there wasn't like a flush or a finish API. But like if I were given this question, that would be the sort of first thing I would start asking about. It's like the point of having a storage is it to be durable, but there isn't really anything in the problem description or even in the underlying library that is related to durability.
Yeah. So I think if I was doing this, I would copy this into it. I mean, I am about to do this, right? So I would copy these because I think in comments, as you know. I don't know how I make a new file. Design.txt. I would copy this, maybe delete it.
So normally in an interview setting, you might be working on a whiteboard if you're in person, or maybe working in a Replit if you're doing it like over the phone or remotely.
Yeah, I think a lot of folks use docs and stuff these days. Certainly, we've been interviewing virtually at Google for, I don't know how other companies do it, but like at Google, we've been interviewing virtually for years now. I mean, a couple of years now, particularly with the, pandemic and all. So then I would just sort of think through in comment style, like what I was going to do in these. And then I think another thing that I would try and think about is like, what are my like test cases, and what are my assumptions, and what are my invariants? Would be other things I would think through.
Yeah, I think an important part of this problem is you're given this sort of fixed sized blob. Like it says, the maximum blob size is whatever it is, 256 kilobytes. But the maximum file size that I'm supposed to make is, I forget what it said, but vastly larger than that. Right? And so there's going to be a question of like, like how am I going to take many of these blobs together and make them into one file? Hi, Alan. Thanks for joining us.
Because file size. Okay.
And there's a similar kind of question of like, so fopen implies like, oops, sorry. We could fulfill it. Like, I'm going to somehow need to find a mapping from names to files, right? Fopen and remove that are going to be mutating. Like I have to be able to find and recover the files.
All right. So what is this blob? So okay, we have a get our free space. We have a get blob. Okay, which presumably can fail. Have cool Need to answer?
Answer Zeppelin's question?
Yeah. Zeppelin, personal question, no need to answer if you don't want to. What do you guys work on? What do you do? I'm just curious because around your channel that you guys have cool content. Well, we both work at Google. We have both worked together many times, although we don't currently work on the same thing. I work on Flutter. I lead the Flutter team for Google.
I work on Fuchsia. I have worked on Flutter in the past. I worked on Flutter fairly early on.
Yeah, you're still one of the top committers of all time.
Somebody will catch up to me.
Yes.
So I think interesting question here is like, how do you allocate a blob? Like, do you just make up an ID, and then it gets like these are sort of like that's a question I would ask given this interface. It's like,
yep. Okay.
I'm kind of assuming that you just make up an ID because I don't see any other way of like.
Yeah, it must be. Well, and this must be able to fail, or if it can't ever fail, if you can like.
Well, that's another good question. Is like, can this fail? Like, if I've stored a blob before, is it durable forever, or is it could be evicted, or could be corrupted, or what are the guarantees that the blob store is giving me about durability? Because it makes a big difference, right? Like, suppose the blob store is allowed to fail 1% of the time, then the file system has to deal with that and use some kind of, error correction or something.
Again, if you're actually in one of these interviews, this is the point. At least I think of this as being the point. Asking questions.
Yeah, then like it's not obvious. Like there's no right answer, right? Like it could be the blob store's job to do like error correction, or it could be the file system's job. It's just a question of like you put all these layers together in your storage stack, and where do you want to solve which problem? Like that problem's got to be solved somewhere, but you can pick where you want to solve it.
All right, so this is get free space. What is what happens when you run out of space? Presumably get blob with a unique ID just fails with none or with null?
Yeah, so the question like how does it report errors? Like he's got some declaration of like error codes, but it wasn't obvious where those error codes come out. Another question that I would ask is the free space. Is that like presumably the blob store has some kind of storage for the actual payloads of the blobs, but then creating or working with blobs is going to have to consume some space for metadata or some space for journaling or something like that. And so it's free space like inclusive or exclusive of metadata. Like I suppose somebody said, oh, I want to write like a gigabyte of data to this file. And he said, okay, I have exactly 1 gigabyte in free space. Does that mean I'm guaranteed I'm going to succeed? Or could I still fail?
I would assume and design around, well, I mean, you'd like to not have this design restriction if you don't have it, but I would assume robustly to design around the idea that even if you say it has enough space, it still can fail. Am I crazy out of focus?
Yeah, but that's okay.
Whatever. Okay.
I feel like I have less questions about the C interface because the C interface is pretty standard.
So this is once we get a blob. Can this fail? Presumably not, since it's returning a reference.
But it looks like put can fail because it can run out of space.
And that must be what the error.
Yeah, I assume those insert error, like those correspond to those error codes.
Okay. Oh, interesting. I see. So you could imagine that the implementation, although again, since this is a pointer return as opposed to a reference return, this could always succeed.
And just fail. Well, on get, I see. If the thing was out of space, maybe you just make up an ID.
Yeah,
it
you
gives
just
you back the blob.
back a blob. It's just you might be getting back the error blob, right, or something like that. For which all of these things, because here's where the actual error codes are exposed.
Mm-hmm. So another question I would ask is about like durability. So suppose something that could happen is that the power could die, right? And so the question is, who is responsible for keeping the blobs in a consistent state? Like, is the blob store always going to be in a consistent state relative to some operation thing? Or does the file system need to be prepared for the blob store to be inconsistent? In which case, the file system needs to do some kind of journaling or some other kind of strategy for maintaining its own consistency.
So, what would it manifest for the blob store to be in an inconsistent state? I don't disagree with that, but the question is,
yes, like a simple experiment you can run would be, let's say you get 2 blobs. Mm-hmm. You call put on the first blob and it says, yep. And you call put on the second blob and it says, yep. Mm-hmm. Is it ever the case that I could see, if I were later to get the data, I would see the data for the second put, but not the data for the first put? Typically, the way these systems are, a common way to do these systems is you queue up all the writes, and then you actually like flush them to underlying storage at some time later. And then typically they're designed to, they can't, like, it's a big design consideration about how ordering is preserved, like whether it's possible for the writes to hit storage out of order. Like an example of this might be, suppose the blob store is implemented by a cluster of machines, and each machine would flush to its own disk in order. But if one blob was in one place and one blob was in another place, one could hit disk before the other.
Yeah, which would be a totally reasonable thing for like a large scale, cluster. Like, yeah, I don't know how something like Gmail works, but you could imagine something like that. where you want rights to be local to an account or something like that, but not, across.
You even get this on a single machine, like these days. If your underlying storage media is, let's say, Flash, and you have several Flash chips, and you have a Flash controller that you write to, and it generates separate write queues for each of your chips, they're not necessarily going to be globally. The global order may not be consistent.
So a question I would ask is, what happens if you get two handles to the same blob, and then write to one and put to one? Does the second one get updated, or is the second one like a local cache? Like what does it take for a blob to get updated? Do I have to always get the blob again?
Mm-hmm.
I don't know.
Yep.
And all these things are going to bleed through into your file system, depending on what. And this is why it's challenging to implement, something like this, matching Linux or Windows or whatever, is because that all of those assumptions of their underlying implementations are bleeding out. Certainly, this happened on the web.
Yeah, so like POSIX has made a bunch of choices about how exactly like writes from multiple threads and multiple processes, like how they can later be read back, and those choices are based on the internal structure of their storage. And so that's part of why it's difficult to build a like distributed network file system and get perfect POSIX semantics. It's because they're kind of assuming that you're going to bottom out in a kernel where you can take a lock, and you may not be able to do that in a distributed system. And so that's why people design other storage mechanisms like databases with various different semantics.
All right, so maybe we should make some assumptions, or should we attack this, since again we don't have an interviewer to make these assumptions for us?
You should just sketch out like a basic file system. So like there are lots of different approaches to file systems. Like the one that I think is reasonable is to basically treat directories like sort of their own little files. Mm-hmm. And so then the question of like, how do I do name lookup becomes sort of like you sort of internally use the file system itself to do that. And so then the sort of more basic question becomes, how do I assemble what appears to be a contiguous region of storage out of these little blobs? And then how do I name that, typically with like a integer identifier as opposed to a string identifier? And then you separate the problem of then how do I translate the strings into the integers?
Yeah, I think there's also a question of performance characteristics, both what the desired performance characteristics are on the consumer side, and also what are the performance characteristics of this store that we're being handed. Like, for example, if
I think a good example is like if this
blob is super slow,
mm-hmm.
right? You would really want to put a lot of effort into optimizing that you only ever use one blob when you can.
Or even the like expected workload of the client API. Like if suppose you have a very write-heavy workload, you may pick a structure that's more just like recording all the writes, and then later if someone wants to read it, if that's an unusual operation, then you do a lot of work at read time to reassemble it.
Because you could, for example, store multiple files per blob. You could also store the entire directory in a single blob.
Mm-hmm.
All of these things, again, depending on what the behavior characteristics, like what are the fast APIs, what are the slow APIs?
Mm-hmm. And like what is the ratio between like creating and destroying files versus editing existing files?
Yeah.
For a lot of these things, like because a file system is such a very general tool, you kind of like, unless the interviewer gives you a very specific workload, I would kind of assume like a normal general purpose workload.
Well, that's the thing, is that this is actually a very difficult API to work from, because again, you don't know who is consuming this. So an interviewer also is going to be like, part of your job is to generate the fodder of these kind of discussions, and the interviewer is then going to guide you towards where they want to go. Right? They're going to say
you'll end up, yeah, and then you end up like discussing trade-offs, like
yeah.
So like, what if that were very expensive? What if that were expensive? How would that affect your design?
Yep.
We have another comment here.
In contrast,
okay.
Go ahead. In contrast to entry-level software engineer interviews, are senior software questions more system design based rather than traditional data structure based coding questions? The short answer is yes, but you've probably done more SWE interviews recently than I have.
It depends. Like this is a type of interview. You'll get other kind of interviews that are different. Like um, I also think it's important to interview for like coding skills. Like I don't think it's. I think someone who has this kind of position should be able to like take out a piece of paper and write a bunch of code too. So like that's an important thing to test in the interview process. I wouldn't assume that they can do it just because they can do design.
Yeah, I feel like there's I don't have like a neat system for this, but there's different aspects that I'm doing when I'm dealing with a candidate. There's different roles between when you're an interviewer, at least at a place like Google, which has a large interview pipeline, where you're an interviewer, so you're like a cog in the interviewing machine, versus when you are the hiring manager or someone evaluating the packet for on behalf of the wider company or whatever. But when I'm evaluating a packet, whether I'm a hiring manager or hiring committee kind of perspective, I'm looking for a few things. I want to see their experience, understand what value or their presumed experience, the experience they're presenting, right? I want to validate some amount of assumptions. Like I want to poke, as you said, like I want to see them code, not because I don't believe them, but just like let's validate. You say you wrote C++ down. Can you write a little bit of C++? And
you just don't want to be surprised later. Like you don't want to hire the person and they're like, oh, actually, I only write docs. I don't know actually how to write code. You're like, but your resume, they're like, oh, well, 20 years ago, I wrote C++.
Yeah.
And it happens. People are like that, right?
And so you just want to poke at some of those assumptions. But then you also, again, for the more senior stuff, because so much of it is design, right? Like when you're particularly in these more senior positions, you're doing a lot of code reviews, you're doing a lot of mentoring others, and less just pounding out code.
I just looked at my stats for the past 6 months. So in the past 6 months, I think I reviewed 6,000 CLs and wrote 150 CLs, just to give you a sense of like a ratio between that. So I spent a lot more time like reading people's like code, giving them advice about what they should do, and less time actually like physically typing out the code. Although I do that too. Just I think it's important to do like for my role, less for Eric because Eric's more on the management side. Just to like mostly I do it to just work with the system so that I understand what everyone else is going through. Like what does it take to build the system? Is our build system slow now? Like what does it take to run a test? Like is that working okay? Like where does it hurt?
So 2 things. One is that is very important to feel on the ground. Also, for those of you listening, Adam is one of the most prolific engineers I have ever worked with, and I've worked with a lot of engineers. So please don't feel bad if you haven't reviewed 6,000 CLs in the last 6 months.
Also, like numbers are not like counting CLs is a horrible metric for things. Like,
but anyways, you can be an extremely good engineer and not compete with Adam in terms of total volume.
Sorry, I didn't mean it as like a flex. I just it's performance review season, so I just like literally in the past couple of days had to write up my self evaluation, and I always pull all these data just so, like my manager doesn't have to do it for it. Like,
in any case, okay, so where should we go here?
I think we should look at the idea of how do you take these blocks, these fixed size blocks, and make variable size files out of them. I think that's some of the more interesting part of the problem. I want to do a little bit of math with he gave us numbers like how big are the blocks?
Sure.
How big is the biggest file? Because I want to just get a sense for like how, like in the worst case for the biggest file, like how many blocks are going to be needed to do that.
Okay. Put that in assumptions.
I think the blob max size was in a different thing, so let me copy and paste that for you too.
Oh yeah, I think I already copied that. It's in the blob area. Yeah, right here. Max blob size.
Yeah.
Okay.
So like, what does it actually come out to? Like max file size is, so what is, this is, now we're gonna do some math here.
It's 1024. Is that 2 to the 16? No, it's not that big.
This is like, you should memorize your powers of 2, but I having trouble doing it on demand here. 14. 2 to the 14 is not enough. That's only 16K.
1024 is 2 to the power of 10. That's Wikipedia.
And 256 is 2 to the power of 8. So this is 18.
Yeah.
I can double check that just to. That looks right. Okay. So then if the max file size is this, then
There's
you need
slightly more than 2 of those. Right? No.
No, it's exponential, right? We're gonna need
Yeah.
like, so in the sort of worst case, you're gonna need 22, 2 to the 22 blobs for a single file.
Okay.
Did I do that right?
2 to the 40 divided by 2 to the. Don't hire me for my exponential math. It says that. And so ln, what would that be? Log 2?
Mm-hmm.
We want log 2 of that. Yep, 22. You're right. Good job.
Okay, so that's a lot. Just saying. So like, normally the way like a common strategy for doing this in a file system would be a tree, right? So our blob IDs, so like a very simple tree would be like you'd have one blob that listed out the blob IDs of all the rest of the blobs, and then that. So then you have like one node that didn't actually store any data. It just referenced all the other blobs that have the data.
Mm-hmm.
So I'm curious, like how many blobs full of blob IDs are we going to need? So that's going to determine based on the size of a blob ID.
Well, we don't need more than. Well, how big are the blob IDs?
So it looks like the blob ID is a 64-bit integer.
So that's.
So how many bytes is that? That's like 8 bytes or something? 16 bytes?
Well, a byte is 8 bits, and 64 is 8 times 8. So 8 bytes. 8 bytes. And
so then how many blob IDs can I fit in a single blob?
2 to the 20. That's going to be 2 to the 26, right? Because this is just 2 to the 4.
This is 32K. So I think I can do 32K blob IDs per blob.
Well, we decided this was 2 to the 18, right?
Yeah, we should.
Bytes? Is that right?
Yes, 2 to the 18 bytes. And 8 is 2 to the 4, right?
I believe so.
2 to the 3?
Maybe it's 2 to the 3.
So then it should be 2 to the 15.
Yeah, you're right. 3. Okay, so
then we're going to need at least 2 to the 7 blobs full of IDs to address all the content blobs.
This is where I might poke the interviewer and be like, "Are you really sure you want to design it this way?"
No, but I think this is exactly why he's like. I suspect he's chosen these numbers so that these things end up somewhat interesting.
I mean, this is you would like to. If you're going to end up biasing towards large files, I mean, that's again a question about like what is this system going to be biased towards, right? Like if you're writing a file system to store, video files or whatever, this is not the right design.
Well, a typical strategy actually is you basically have like the basic file will just be the blob, right? And then you'll say, okay, this file is actually an indirect file, which means it has one of these meta like ID full blobs.
Yep.
Then you'll have doubly indirect and triply indirect.
Yep.
And typically a file system just has a limit. Like I think, I don't remember what X has, but I think X only does triply indirect or whatever. That's how deep the tree can be. And so in this world, because you only need this many blobs, I think you only ever need doubly indirect files. because you can like imagine you had, because you can fit this many blobs in a single blob, then you can address all of your addresses, all the blobs that are full of the content blobs. The addresses of all those blobs can fit in the one root blob. So I think the conclusion, only need doubly indirect.
Yeah,
it's
so
nice. That's a simplifying assumption.
You do need some sort of metadata now in the blobs, some sort of header that tells you, is this a raw file? Is this a...
And so typically you would put that in the directory. So in the directory, you'd say file foo is rooted at blob 26 and is doubly indirect, or whatever it is.
Okay. Makes sense.
Giphy. Hi, Giphy. Yeah, there are more advanced strategies where like you don't want to hit these cliffs where you're like, oh, now I'm a triply indirect thing. Let me like reshuffle my entire universe.
Yeah.
So you tend to basically, it's probably because you have so much space here. Like notice that we only need 2 to the 7 and we have 2 to the 15. So you probably end up just like biasing your tree so it's not of a uniform depth, but like the early parts of the file are close to the root, and as you start getting close to the end, then you start being, oh, now instead of actually putting data in the 2 to the 16th like data block, I'm going to make that one my indirect block.
So I would challenge you a little bit there. I think this is back to the giraffe vending machine question about like who's going to use this, because like you would definitely want to bias it, differently depending on.
Oh, you're saying suppose this thing is always used to store like these huge files, like. Then it's not worth, like you just optimize for that. Be like, this is the petabyte store.
Yeah.
That's what the title of the thing is. We're going to store these very, very large files.
Yeah.
I think that's a good point.
Okay, I do think it would be interesting to sketch out. Well, I'm not sure we have time for it, but like, what this sort of indirection looks like. Let's maybe take a brief look and see what other sort of interesting problems lie here. Like, so this needs to get through the indirection to get to the underlying store and then stitch them together and hand you back some thing that knows how to walk through them, right?
I think we should just do a sanity check. So like if our plan is to store directory entries in the sort of same kind of object store that we're going to store the data, we should just do some math with his numbers to check the number of files and the max file name just to make sure that's going to fit. Like imagine you put all the files in one directory. Like,
yeah, how many directory nodes do you need?
Yeah,
I suspect, and there again is a question of like, do you want to have a single directory node, or do you want to have a tree of directory nodes, or how do you handle that?
Right. So let's see. So the file names is, so this is 2 to the
This is
9. Yeah, he's put a little trick in here. Look at that. So the file name is 2 to the 9. Max file name is 2 to the 9. And the max number of files is 2 to the 32, or 2 to the 33, which means just to store the file name, so the biggest possible directory is going to be 2 to the 42. This is bigger than the max file size, and so probably. Then you also got to figure you need a little bit of space for that to like reference the like the root blob or whatever.
Why do you always have 2 root blobs?
What do you mean by 2 root blobs?
I mean, like a solution here would be if you, instead of just having one directory node, you just have I guess, but it's not more. It's
this is all like worst case scenario planning. Like
sure.
Like this is saying all the files are going to be stored in one giant directory. It's probably I don't know. That's the realistic use case.
And there again gets to the question of assumptions, right? Are you storing a few really large files, or are you storing a zillion tiny files?
Anyway, but I suspect if you actually analyze the directory problem, you'd find that you wanted to design for a max file size that was a little bit bigger than what he's saying the max file size is. Based on the numbers that he's got here.
Yeah. Okay. Happy to do other things. My bias would be to sort of look for other long poles in the, scan through this. So like for this, we need to like understand how to open the directory, find the blobs, and then like load, and then like create some file object with blob IDs that knows how to load them, or you could eagerly load them or something.
Yeah, so let's sketch out like a basic thing here. So I think another important thing we need to design is a super block. So typically in a file system, you need to like find your whole file system on disk. So like, I don't know, typical strategy might be to say blob ID 0 is a super block.
Correct. Yeah.
And then you get into like really durability questions, like can the blob store lose blob 0? So what we do in feature file systems, we keep a couple copies of the super block. Like we keep one at the first blob, we keep one at the last blob, we keep one at some prime number somewhere hidden over here, just to like make sure we don't lose the super block. Because if you lose the super block, you're losing everything.
Does that mean, what is your synchronization pattern then for the super block? Do you always write all of them, and then do you wait on your flush until you've written all of the super blocks?
I mean, the way we actually do it is with a bunch of checksums and a journal. So you basically journal what you want to do, and then when you actually go edit the super block, you also write. So the guarantee that the block layer provides is that block writes are atomic. So you try to get the super block to actually be one block. So you can write its content and its checksum atomically. So I guess that's another question to ask about the blob servers. When you call put on a blob, is the put atomic? or does it have some atomicity guarantees? So POSIX has a fascinating atomicity guarantees for writes.
What does?
For POSIX. So if you have like a pipe in POSIX, if your write is below a certain size, I think it's 4K or something, then your pipe write is guaranteed to be atomic. But obviously, if you just have a regular file and you're writing several megabytes, POSIX makes no guarantee that your write is atomic.
Wasn't that like one of the? I wasn't working at Google then. This was a long time ago, but I feel like at the time I was hearing that like one of Google's innovations was that they had just used flat files, on servers. That they had moved away from. I feel like the industry was like adopting SQL and stuff at the time, and Google was like, no, we're just going to use like a simple flat file.
Yeah, so that's kind of what I'd recommend here for the directory, just as a simple thing is like, what if the structure we use for our directory storage was just the name of the file and the reference to the blob, and we just keep them in sorted order. And then when a lookup is just like a binary search, and then an insertion is just you add to the end, and then you do some kind of sorting algorithm to clean it up.
Yeah, there's other questions about. This gets back to like what performance matters. What performance are you optimizing for writes? Are you optimizing for reads? Or
so there's actually the folks working on file systems in the future right now are doing a really neat file system, which is they call a log structured merge tree. And so the way this thing works is basically you just start out with like the dead simplest file system structure you can think of, and then over time you can add more layers to your storage structure, that each one is an optimization over the previous one. And you basically work with your clients to optimize them. And so you get sort of fancier representations for things that actually matter. But then because the whole thing is this merge tree, you can keep reading the older, dumber file formats. That's probably too fancy for this this interview question. But
it occurs to me, another thing that if you were actually sitting through one of these is that I would expect an interview to do is eventually they may actually want you to write some code. Like the talking is part of it, but they're probably going to say, okay, so let's take these assumptions and I would like you to write up X, or I'd like you to write some test cases for Y, or again, because I'm typically.
So what I would do in that interview situation is I would give the interviewer some options. Like, would you like me to write the binary search, to do the directory lookup? Would you like me to do, like, there's a bunch of things in here about maintaining the seek offset, which has some interesting like overflow, integer overflow questions. and I would basically ask the question in a way that sort of would demonstrate that I understood what the interesting piece of each of that, or what I thought at least, the interesting piece of each of those pieces of code is.
Yeah.
Personally, I find the seek function super interesting. I've written this function several times, and I've actually written it in like half a dozen different languages, and it's actually really interesting how the integer overflow gets dealt with in all the different languages. And one of the reasons I became a big fan of Rust is I wrote seek in Rust, and it was like, oh, Rust is forcing me to deal with the tricky integer overflow issues here. Whereas if you write it in another language, those are often swept under the rug, and you have to do work to bring them out.
Yeah, so this gets back to the understanding what are the, for me, your mention of seek, like that was a long pull. I don't think I'd even gotten to reading that part of the problem yet.
I think it's realistic in the next 15 minutes, the last 15 minutes of the show, that we could write the seek and tell part of this.
Well, so I need to finish reading here. So, okay. Okay, so open, we have some idea. Remove should be the same as open in a sense that it's finding all the blob IDs and then deleting them and updating the directory, right?
Well, there's lots of questions even here. Like a common thing you do in file system is a lazy removal, where all you do for remove is just mark the directory entry as like, oh, this one is gone. And then sometime later, if you want to go clean up, actually go release all the blobs, or like if you're out of storage, go find them, release them. I think that's why this is a good interview question, because like basically every one of these functions has something interesting to talk about.
Okay. So close. What does it mean to close a file? Does that imply flush? Must, doesn't it?
Normally, I mean that's the case on, for example, Windows. Is a close implies a flush. On Linux, it's a little bit weaker than that. Like I think it's eventually it'll be durable kind of thing. But like in Windows, like Windows will block on close until it actually gets your stuff to disk.
And by flush, for those not familiar with files, it means like written to disk. Like so that like if you call close and then you call open, the open will get you back the stuff that you wrote. Like it got all the way to disk.
Or even stronger, like if you yank the power. Sure. You put up a message on screen that says, yep, user, your data is safe, and then they yank the power. Mm-hmm. What happens when they put the power back in?
And so this may involve waiting on async blob operations or returning some promise. I don't want the long. I see 0 on success, negative on error. So this is sync. So there's no returning a promise. Okay, read. I see file is the thing. So this actually has to go. This is load the blobs. Data, handle errors. Know how to traverse between blobs.
Mm-hmm.
Or the,
like suppose you
how to do that, right?
Yeah, suppose you have like a doubly indirected thing. You want to keep like offsets into each level of the tree, and then as you approach the end of the blob, go up and over and down.
Yeah,
we can try to write that code.
In a non-C language, I would expose some sort of iterator, right? I would I mean, maybe in C I would do this too, but you have to use it with free functions sort of. But I have some sort of structure that knows how to iterate over all of the blob IDs in a file, because I think this is a common operation for read, for write, for delete, to like walk me through them and then do something on them.
Yeah, like it's very common inside a file system to have a more basic file system API internally that you then build these end user APIs out of. It's like you might have a read that only can deal with one block at a time, and then you combine that with the block iterator to then build up a read that can read.
I mean, I feel like what you said is just true of most systems, right? That there's there's layers typically in the system, but there's often a layer, the API layer, that you just, it may be awkward, it may be dumb, it may be not the thing that you want, but it is the thing you have to not change. And so you do the thing that you want and works well underneath, and you make it fit.
Yeah, I just think like you might be tempted to think that the blob layer was one layer and then this layer was the next layer. But I think what you're saying is like you want to have a bunch of layers in between because
Definitely.
there's a lot of adapting to do between the blob and this kind of C API.
So write, I think, is, and as you said, maybe this is interesting, right? This may need to create new blobs.
It like extends the length of the file, for example.
Yeah.
The other interesting thing about the blob API is it doesn't have a partial write operation. So you're gonna have to like get the current data, like scribble over part of it, and then like put it back.
Yeah.
And then there's also like another interesting question is like if the put operation is expensive, you may end up with a caching layer where you've gotten a bunch of the data, you've scribbled over it a little bit in memory, and then you don't actually go call the put operation until, let's say, close time or some other time.
Well, and then again, we get to the question of like, say this is a network file system, right? What if any locking is done around, or what if any sort of guarantee is like, when I get a blob, can anyone else get it?
Yeah, so like release here, I think means like delete the blob, right? But you may want a operation here that's like, I'm done with this blob. Like if I'm going to interact with it again, I'm going to get it, which means whatever distributed locking you're doing is now less complicated because I'm not holding onto it anymore.
Oh. Just like if two people put to the same blob, what is the like right order of that, or what guarantees, if any? How do I know? This is where locking comes in.
So tell is finally an easy one. So you're going to need some basic data structure that's like, here's my file, here's my offset, here's my reference to the blob. This is just going to be like a getter for one of the fields.
Yeah, I mean the file itself is whether the file itself is the object, or but the file needs to point to an object that has all these things like the cursor and the cursor, which is a virtual index into this imaginary file that is strung together on blobs, but also then the thing that knows how to walk through the blobs and
the traditional structures you have.
Go ahead.
You have two. The traditional structures you have two layers of this. Like two people can open the same underlying file, and they'll have separate seek pointers, which implies that there's like you have two copies of the structure that reference the same underlying piece of storage. And you probably don't want to go all the way through the blob store. You probably want to have them meet somewhere in your system, coalesce their reads and writes, and then push to the blob store beneath them.
I heard you say was that the cursor, like we don't know exactly what a file is defined as, but it's at least a cursor plus a data, and you could imagine wanting to share that data or parts of that data between multiple cursor data pairs.
An example is like the length of the file. Probably you want to remember in a place that's shared between all the people who have it open for reading and writing.
Yeah, again, possibly. Are we all on the local system? Like if I change the length of the file, does that update for other people? When does it update? Does it update when I close? Or like all these things are unanswered questions.
This API sort of imply like because it's this sort of POSIX-ish or C-ish structure, it sort of implies a common meeting place where you can hold a lock like that.
Yeah. All right, seek.
Seek is fun because of the overflow options.
So need to handle overflow. I have vague recollections of you dealing with this in WebKit Pi's file system action.
It comes up all the time. I've done it in every language. Oh, another interesting thing that seek gets you at is the idea of sparse files. Like, let's say you write a little bit over here, and then you seek way over here, and you write like, do we need to support sparse file? Like, do we need to actually like populate all the intervening space with zeros, or do we want to have some representation that allows us to skip those?
And do sparse files reserve the blobs? Mm-hmm. Like, what happens? How do sparse files interact with
Yeah, so we were getting this design question in Fuchsia, and so like we started asking questions like, okay, what happens if you have a sparse file that doesn't reserve the space, then gets mapped into memory,
Mhm.
So then the unpopulated region gets memory addresses,
Sure.
and then you take a page fault in that memory region and try to write to it, but there's no space in the underlying storage. What happens? And so then we tested that in every operating system, and like max answer is kernel panic. But you just have to decide like what is the answer.
Mhm.
But you're pretty in trouble at that point because you basically, by mapping the memory, you've kind of committed to it being there,
Mhm.
but then by like you don't actually have it.
Mhm.
Like I think the answer that we came to, um, I don't know where. I think what we wanted to do was Fuchsia in general, Linux overcommits,
You're
and so
well
we
in the
just
bonus points for this question, by the way. If
well,
if
there's
you're
no map operation here,
your
so like,
in your
well,
L7 interview.
but we had this question. We had to decide. Like,
Yeah. Well,
it
that's
just comes.
actually like if you were designing the system, that's why it's important to write it down. Like so much of working with these large teams is writing things down so that you can reason about them and look back at them.
And honestly, just make consistent choices. Like, it wouldn't be consistent to have a system that was not overcommitted, but then also didn't make sure there was space for the gaps in the sparse file, right? Like,
Yeah.
and
Well,
then your team is big enough, like you end up with like tons and tons of documentation, and then you just have to basically tell the story of your system in a way that people can understand and relate to. As you say, you have to end up saying things like they become compressed into these like silly bumper stickers. So like one for Flutter is like everything is a widget. It's a way of communicating the idea
yeah,
that probably when you're designing something new, you should think about it as a widget.
yeah. Well, this reminds me of something I probably talked about this, but like as a manager of large teams, and this is also true in a technical leadership capacity, you are never in the room. That they say you can't always be in the room, but no, you're just never in the room.
The
And
first
so
approximation, right?
yeah, and so the only things you can do is you can manage through incentives. Like, what are the incentives that you're putting on the system to like produce a specific outcomes? What are the things you're rewarding? What are things you're what are your sticks? What are your carrots? And then also through values. Like, what are the things that you've like write down, as you said, to reference back. Like, we make a system that never overcommits, or we make a system that never ooms, or that never panics, or like
Also, for a feature, we say no ambient authority is one of our bumper stickers.
what?
No ambient authority. You can't just like reach out in the air and grab something. You have to have been given a capability to access that thing. And so then people, every time they're doing something, they can reference that idea and be like, "Oh,
Yep.
I'm making a thing that's grabbing it out of the air. I wasn't. It's not the right thing. Well, what was I supposed to do again?"
Because
The thing I found,
what you say?
the thing I find totally fascinating about this, by the way, is the same effect where there are all these famous quotes from movies,
Mm-hmm.
and then those quotes, the ones that get repeated and talked about, are never actually the ones that are in the movie, right? Like "Play It Again, Sam" is not in Casablanca. Like,
Okay.
it's somehow been worked over by the collective conscience of our society, and we've improved on the script of Casablanca.
Huh.
And so there's the like next level of the bumper sticker thing is like you're never going to be as good at creating these ideas as the collective wisdom of your team. And so how do you get the "Play It Again, Sam" version of your bumper sticker that you're not clever enough to write down, but by bouncing it around however many people over however many years, it becomes refined, distilled to that.
Well, this gets back to the incentives and the sticks and carrots and the like. Your job is less to come up with Play It Again, Sam, and more to see it and promote it. And when the bad Play It Again, Sam is taking off, to demote it and manage it out. And um, anyways, we're heading towards the end of our time.
Yeah, we're sort of waxing philosophical.
Well, I mean, this is my job now to wax philosophical. This is always fun.
Yeah, I think it's fun. It's a little different episode. Like normally we spend our episode like furiously banging out things on the keyboard. So I think it was neat to do a little bit of a design, a little bit of like how to approach a senior interview, things like that.
Yeah, so I think for those of you who came here looking for senior engineering advice, we probably didn't cover exactly as the interview, but I do think major point that I would try and take away is that there certainly are interviews. I've certainly participated in interviews on both sides of the table for senior where it is not just writing code. It is about exploring the thoughts and the design and the asking questions and having a conversation.
Yeah, if you're doing math with powers of 2, you're probably on the right track. Like, it's kind of get in the ballpark of like what we're talking about.
Any other thoughts before we leave you for a week, Dr. Barth?
Not particularly.
Yeah.
Sorry, that was just like I didn't yes and your.
We are making fancier pizza again this week. We've decided the pizza steels, if nothing else, were the right investment. Although I think if I was really making pizza a lot, I would get one of those outdoor pizza ovens, because it turns out you can get like a small outdoor pizza oven for the pizza steels were a decent chunk of change to get in the first place, and for a couple multipliers on that chunk of change, you can get a really fancy pizza oven. But the pizza steels were great. We're making the fully fancy pizza this week, and we'll report back and tell you how it was.
So we recently got a solar oven, which basically collects the light of the sun, directs it into this vacuum tube where it can't escape thermally, and so heats up this like cylinder up to like 500 degrees. And we successfully used it to bake bread using only the light of the sun.
You have blown my mind. So you're ready to go off grid with your bread baking, is what I'm hearing.
We can bake bread off grid now, yeah. With like it's like the most sustainable thing possible. Like you just take the sun, you direct it into the dough, and you get out bread. There's no like electricity involved.
Love it. So, anyways, this was fun as always. We'll see you next week. We're planning out what our next run of episodes are. So if you have ideas, I know that there's been some requests for future episodes. We're working on that. But if you have other ideas, tweet at us. We would love your suggestions as to what you'd like to see on the show. So take care, Adam. See ya.